Assalamu alaikum dear friends. In our previous video we understood about Dijkstra algorithm. Dijkstra algorithm is a algorithm with the help of which we try to reach all the points in a graph starting from a single point, and we try to find the shortest path. It is basically a greedy algorithm in which we are trying to find the optimum solution. If you want to develop a better understanding about this Dijkstra algorithm, please go to my previous video. Otherwise, in this video, we are going to solve a very important example which can actually, or similar question can appear actually in your exams. So, if you haven't liked the channel, do like and do subscribe. And now let's proceed with me. So, friends, first of all, we are given a single source 1, and from the single source we are supposed to find single source shortest path for this undirected graph. So it means you are given with an undirected graph. What is an undirected graph? It is a graph in which there are no arrows, no directions marked, so you can go from this point to this and from this point to this. But right now in this Dijkstra algorithm, we have been told that we have to calculate the shortest path starting from this single source point. So our source point is 1. So first of all, if you want to solve this question in a very appropriate manner, you have to make this table. In this table, you write that my source is node 1 and my destination will be node 2, 3, 4, 5 and 6. So basically, out of these 6 nodes, one is your source node and the remaining 5 are your destination nodes. So how do we initiate the problem? We initiate the problem by assuming that the cost to reach all these nodes is infinity. We say that if you want to reach from this node to this node, the cost will be infinity. So this is my initial assumption. And in the next steps, I'm going to relax each and every of these costs one by one. So how do I proceed? First of all, I'm going to say that direct cost to reach from node 1 to these remaining 5 nodes is for 1 to 2 the cost is 7, for 1 to 3 the cost is 9, for 1 to 4 is 1 connected directly with 4? No. So I do not know the cost. I do not know direct cost. So I will just follow the infinity as it is for 4 and 5, both the points, because they are not directly connected with 1. And for 6, the cost is 14 because 1 is directly connected with 6 via this line and the cost is given as 14. So now I can say that the nodes which were directly connected with the source node, they have been relaxed. Their costs are no more infinity. The costs have been relaxed. All right. So now choose the minimum, which is now relaxed. So out of these 7, 9, 14, we are going to choose which one is minimum. So of course 7 is minimum. So bubble it up for your ease. And now you say that your initial cost of your node 1 and 2 have been relaxed. So now in the next step, you will assume that 2 has become part of source. So you can initially you used to move only from 1 to other nodes. 1 was your source, but now you can even move from 2 to other nodes because 2 has also become part of your source. So assuming 1 and 2 as your source, now let's start this similar step of relaxation once again. So now we are going to relax all those nodes which are directly connected with 1 and 2. So 7 was minimum, it will travel as it is. We do not need to reiterate it. Let's see for 3. 3 is connected by this cost of 9 with 1. We wrote it initially. And 3 is connected while this cost of 10 with 2. This is a larger cost as compared to this, so just forget it and let it remain 9 as it was in the previous step. Let's explore node 4. Node 4 is connected by cost 15 by node 2. You're not going to write just 15. Always remember, when we are talking about Dijkstra algorithm, Dijkstra algorithm is a single source shortest path algorithm. So it will still assume, it will still remember that my source node was given to me in the question as 1. So you always have to add this cost of 1 in every other cost, because if you are on 2, you initially reached on 2 with the cost of 7, so you are going to add this 7 into the cost. 7 plus 15, 15 is the cost for reaching from point 2 to point 4, and 7 is the cost for reaching from point 1 to point 2. So this cost will be written as 22, not 15. Do not make this mistake. Okay, now let's talk about node 5. Node 5 is not directly connected either with 1 or with 2, so we will keep its cost as infinity. Now let's talk about node 6. Node 6 is directly connected with 1 while by a cost 14, as we mentioned in the above step as well. So now these 1, 2, 3 and 4 costs have been relaxed. Out of these relaxed costs, which one is minimum? Of course this was is minimum. This was already minimized in the previous step, so in this step this one is minimum. So I'm going to bubble it up, and on the basis of this 9 I can say that basically my nodes 1, 2 and 3, these three nodes have been relaxed because it also had the minimum cost in this step and it had the minimum cost in previous step. So now these nodes 1, 2 and 3 have been relaxed, and these three nodes have become part of my source, right? So we can take path via 1 and 3 as well, because 1, 2 and 3 both have become my source. So now in the next steps to come, I am going to find out direct connection of the other remaining nodes, either with this or this or this. All of them are available to me. So 7 was already minimum. Let's just take it as it is. Do not iterate it. 9 was also minimum. Just take it as it is. Don't iterate it. Yes, let's think about node 4. Node 4 has a connection by this cost of 11 with 3. So if I add 9 and 11, it becomes what it becomes. See, 9 and 11, 20. Okay, node 4 has another connection with 2 because 2 is also part of my source. This cost is 15 plus 7. 15 plus 7 becomes a larger value. It becomes 23. So I will not consider it. Node 4 has no more connections. So this one is the shortest path connection. So I'm going to take this one here. Node 5 has no direct connection, neither with 3, nor with 1, nor with 2. So this cost will still remain as infinity. Node 6. Node 6 is connected directly with the cost of 14 with my node 1. Node 6 is connected with this cost of 2 and 9. This is another path of connection for 3, because remember that 3 has also become part of your source, but you cannot take this cost alone. Always in Dijkstra algorithm you have to add this cost as well, because your source, your initial source was 1, so never forget it. So 9 plus 2 is 9. See, 9 plus 2, yeah, we are talking about 9 plus 2, yeah, it's 11. So of course 11 is small. In the place of 14 we take 11. So previously the cost, which was 14, has now been minimized to 11, right? And out of these all the costs, of course 11 is minimum, so we bubble it up. Do not compare with these two, you have already minimized them. Right now I'm going to compare with 20. Out of 20 and 11, of course 11 is minimum, so I have bubbled it up. So with this I say that 1, 2, 3 and 6. 1, 2, 3 and 6. These nodes have been relaxed, right? They have become part of my source. So if they have become part of my source. What does that mean? I can find the cost of the remaining nodes with the help of these 4 nodes, right? So I'll simply take this 7 and this 9, and of course this 20 as sorry, I'm on this step. These two values have been brought down as it is, and this value has also been brought down as it is because they were the minimized values. The only thing, this 20. Okay, so let's see what is the path for 4. So you see the node 4 is on this point, and you have one path like 7 and 15, and you have other path like 9 and 11. So of course this is the small path 9 and 11, so we brought it as it is down there, right? It is not further minimized. So now let's see for the node 5. Node 5 has a connection 14 and 9, because now 6 is also part of your source. This is one connection, 14 plus 9 to so 14 plus 9 becomes how much? 20, 24, right? So one path gives you 24. And other option can be 9. Yeah, the other option can be 9 plus 2 plus 9. Yeah, so the other option can be 9 plus 2 plus 9. So I think 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, 20. Yeah, this gives you 20. So I think this is a better option. Instead of 24 we can get 20. So we follow this path. From here we are going here, then here, and then here. 9 plus 9, 18, and plus 2 is 20. So this cost also becomes 20. Now what? This 20 and this 20 are equal values. So what you say, which one is minimum? Anyone can be minimum, because these are two equal values. So we can either choose this as minimum or this as minimum. It does not matter. So whatever you take minimum, just simply drop these values same down here, and this was also minimized, so same down here. So it's just this cost we are going to calculate. So again we have these two same options. We can go on to the node number 5 by where is 5? Yeah, here is 5. So we can say that 5, 15, and 6 is one option. See, this is 5, this is 7, this is 15, and this is 6. So this is one path. We can go from here to here and here to here, because recently we have added node 4 into our series, so we are just exploring it. But of course the answer is 28, which is very large, so we will use the previous value of 20, and the value will no further minimize, it will just come down as 20. So now you can see, friends, that all the nodes have been minimized. So just stop the Dijkstra algorithm here, because we do not need to do any more. We have already done a lot of iterations. All our nodes have been circled, all our nodes have been minimized, and all the nodes have become part of the source now. All the nodes have been connected. What Dijkstra algorithm wanted? It wanted to reach all the points, all the nodes from the source point by following the shortest path. So we have already tried to calculate the shortest paths. We have reached all the nodes, and this is how we have done all the connections with the help of Dijkstra algorithm. So this is how we solve the graphs, and this is how we use a single source, and we try to find the shortest path of all the other points from that single source with the help of Dijkstra algorithm. These steps, in which you initially consider the cost as infinity, and then one by one you try to relax these costs. First of all, direct costs are relaxed. These are all those nodes which are directly connected with the source, and after that, out of these direct costs, you select the minimum cost, and with the help of that minimum cost, you make that node also part of your source. So now if your source is larger, you can connect even more points with the source, and when you connect more points, then out of those points, do not forget to add the initial cost. You always have to start from 1. You cannot simply take from 2, that if this node is connected with 2, okay, just take 15. No, never do that. Add the initial cost always into the cost, and then out of those calculate the minimum one and simply take down that bubble as it is, and calculate the remaining costs by making that point also part of your source. So now you have a bigger source, so you can connect more points, and because of that your 4 is also now becoming part of your connections. So this is how the algorithm works from one step to another, and you will end it when all your points become part of your source. So if you like the explanation, don't forget to like and subscribe the channel, and wait for my next videos. Allah Hafiz.